Okay, so here's part 2 of our trig review, and we're going to focus on exact values. So this is something like, for example, if you wanted to find the cosine of 30 degrees, or we could call it the cosine of pi over 6 radians. Well, you could put it into your calculator and get a decimal approximation, but that's not exact. We want the exact value. And for some degree measures, we can find the exact value because we can use certain kinds of special right triangles like 30, 60, 90s and 45, 45, 90s. So what I'm going to do is walk you through quite a few examples to remind you of how we did these problems. And if you find that you need more explanation, please let me know. I can help you kind of go back to the beginning on it, or just point you to some of the videos I made last year. So let's say we want to find the cosecant of 225 degrees. Well, the first thing we want to do is draw a reference triangle. So in standard position, we would start with our initial side right here on the positive x-axis. We would go counterclockwise 225 degrees, and we would end up with our terminal side here in quadrant 3. From there, we bring up a perpendicular so that we have a reference triangle. So this triangle here in purple is our reference triangle. Now inside the triangle is a 45-degree angle, because if we went 225, we went 180 plus 45. So we have here a 45, 45, 90 triangle, and a 45, 45, 90 triangle has sides in the ratio 1, 1, square root 2. Now if you go down, it's the negative direction, so I put a negative. And if you go left, it's the negative direction, so I put a negative. Okay, so once you have your reference triangle and your sides labeled, you're ready to find the cosecant. Remember, cosecant is the reciprocal of sine, so instead of opposite over hypotenuse, we have hypotenuse over opposite. Square root 2 over negative 1, and we'll just call that negative square root 2. Okay, let's practice a few more. So we have cosecant of 150 degrees. Oh, let's move on to one that's not cosecant. How about cotangent of 300 degrees? All right, so 300 degrees would be quadrant 4. So here's the initial side. We go counterclockwise 300 degrees. So we went 90, 180, 270. We went another 30, which means this angle here is 60. So let's bring up the perpendicular. And our triangle here, our reference triangle, is a 30, 60, 90. And a 30, 60, 90 always has sides in the ratio 1 to square root 3, where 1 is on the short leg across from 30 degrees, 2 is on the hypotenuse, and square root 3 is on the long leg. Square root 3 is always across from 60 degrees. Okay, we went down, so I'm going to put a negative on the square root 3. Now for cotangent. Cotangent is the reciprocal of tangent, so instead of opposite over adjacent, it's going to be adjacent over opposite. So 1 over negative square root 3. Rationalize that by multiplying the top and bottom by square root 3, and the answer is negative square root 3 over 3. Now remember, these problems could be given to you in degree measures like these, or they could be given to you in radian measures and you convert to degrees and then you figure it out. So let me skip down to one of them that I do a different way. How about cotangent of 270? 270 is what we call quadrantal. Remember that quadrantal angles are multiples of 90. (0 degrees, 90 degrees, 180 degrees, 270 degrees, 360, etc. And the way I like to find the exact values for the quadrantal angles, as we saw in part 1's video, is to use the unit circle. The unit circle has radius 1, and any point on the unit circle has its x-coordinate as the cosine of the angle and its y-coordinate as the sine of the angle. So that's really convenient if you're at the point here with coordinates 1, 0, if you're at the point here with coordinates 0, 1, if you're here with negative 1, 0, or if you're down here with 0, negative 1, all you have to do is look at those x and y values and you'll know the cosine and sine. If you need the tangent, remember tangent is sine over cosine, so you would do the y-coordinate over the x-coordinate. Okay, so cotangent of 270 degrees. You don't even have to draw the circle. You can just imagine the circle, locate the point on the circle, think about its coordinates, 0, negative 1. Cotangent is cosine over sine. So the x-coordinate over the y-coordinate would be 0 over -1, and that's 0. Okay? So obviously there's a lot of other problems here on this worksheet, even to the same apparently at times. And I have another part right there. So I think what I'll do is maybe 2 more with you, and then if you want more practice, you could pause the video, you could do some of these practice problems, and then you could check your answers. So let's see, how about cosine of 210? So where's 210? Initial side, counterclockwise. 210 takes you 30 degrees below the x-axis. So then that angle in there is 30 degrees. Make the reference triangle. Across from 30, you always have the 1. Hypotenuse is 2, and long leg is square root 3. Going left is negative, going down is negative. Cosine is going to be adjacent over hypotenuse. So we have negative square root 3 over 2. Okay, so what I'm going to do is pause, figure all these out, and then resume. So what you can do if you're going to do any of these for practice is same thing. Pause, figure them out, and then resume and check your answers. Okay, so here we go. I have filled in the answers to all these problems. So if you chose to do any, you can check those. And then same with the other page. All right, so here's today's assignment. Let me know if you have any questions. Thanks, everybody.